In this video tutorial, we're going to look at how to find distance from a speed-time graph. Now recall, distance is the area under a speed-time graph. Now luckily, the areas are pretty easy to find. There are two such areas you have to be able to calculate in order to do this particular skill. One, you need to be able to find the area of a rectangle, which, in case you forgot, is length times width. I'm going to write it, instead of length times width, I'm going to write it base of the rectangle times height. The other one is that of a triangle. A triangle is simply half of that. It's going to be your base times your height divided by 2. Now, with this activity, we're asking you to take a speed-time graph, calculate the distances, and then plot these distances as cumulative distances away from 0 as time goes on. And then we see what the position time graph will look like. We're going to go ahead and take a look at number 2, and that will allow you the opportunity to practice number 1 and number 3 yourself. In number 2, we need to account for different regions, and so I'm going to segment this graph into different parts. The first one I notice is that there is this big thing right here. Now, that is too much to find the area all in one shot, so I'm going to break this up into different segments. Here's 1. Here's 2. Here's 3. This one is actually 4, but since the flat line is 0 here at the bottom of the graph, 0 meters per minute, that one actually is going to have an area of 0. We'll come back to that one in a minute. And then this big long one here actually has 2 rectangles. So let's break this up into a big, tall, skinny rectangle, and then, so we have a big, tall, skinny rectangle, and then a small rectangle. Okay, so how do we break this up? Well, I'm going to break this up right here, this trapezoid. I don't happen to remember the formula for a trapezoid off the top of my head, so why do that when you can break any trapezoid into a combination of rectangles and triangles? So that's why I'm going to refer to this as area 2 and 3. And so for 10 to 30 minutes, this distance is going to be this combination of area 2, 3. This is area 4. Area 5 is going to be 0 because there is no area. It's a flat line at the bottom. Area 6 is going to be this tall one, and area 7 will be this part over here. So over on the side, I'm going to make some numbers that represent my area calculations. Okay, and then what I will do is I'm going to put the area calculations and the time interval for which those areas are accounting for the distance. So first one. The first one is this segment right here. Now, that segment would be 20 times 20, meaning in the first 20 minutes, we have an area of, 20 times 20, or 400 meters. Because remember, the unit would be meters per minute, but when you multiply meters per minute times minutes, you end up with meters. So it's 400 meters in, I'm going to move this over just a tad. Okay, 400 meters in from 0 to 20 minutes. Okay, so for that time interval, we're going that far. Next one, we're going to have to break this up. So I'm going to have to find segment 2 and 3 and then add those two together. So I probably should leave a little bit more room for number 2 since it's more involved. Okay, so number 2. Okay, there we go. Number 2 is that little triangle. That little triangle has a height of 20, right, and a base of 10. So 20 times 10 would be 200, but then you have to take half of it because it's a triangle. So this one would be 20 times 10, or I guess we're doing base times height, 10 times 20, but then we need to take 2, divided by 2. So 200, take half of that, would be 100 meters from 20 to 30 minutes. And we need to add to this area 3. Now area 3 would be this rectangle right here. That's actually a square. So 20 times the 10 would be 200 meters. Again, for 20 to 30 meters. So all in all, area 2-3 is going to be 300 meters for 20 to 30 minute time interval. Okay, so I had to basically find the triangle, find the triangle, find the rectangle, and add them up. Area 4, okay, is this big, tall rectangle right there, and that one has a base of 10 and a height of 40. So that one has an area of 400 meters, and the time interval goes from 30 to 40 minutes. In number 5, we have no area, so we have an area of 0. Okay, and what that basically means is we didn't go anywhere. We don't have a distance. So for a total of 10 minutes, from 40 to 50 minute time interval, we didn't go anywhere. Okay, that's going to be a flat line on our graph. You'll see what I mean when we plot it. Okay, area 6 is this big tall rectangle here. Okay, and that one has a base of 5 minutes and a height of 60. So in this case, area would equal 5 times 60, which is 300 meters from 50 to 55 minutes. And then lastly, the little rectangle at the end, rectangle number 7, has a base of 5 minutes also, but a height of 20. Which would be an area of 100 meters for the last 5-minute time segment. So here's what we do to plot this, okay? We're going to go over to our graph and we're going to plot a dot that represents how far we went for that time. So we are starting this at 0, 0. Okay, we're starting from the origin. Then, for the first 20 minutes, we have gone 400 meters. So you're going to go over to 20 minutes, you're going to go up to 400 meters, and you're going to plot your first dot. Okay, here's the first one. Then we're going to account for the next time interval, which is the 20 to 30 minute time interval, and we went another 300 meters. So now you have to add 300 to 400. So you can see the scale here, guys. The scale is going by 200. So that's 200, that's 600, that's 1,000, and so on. So that means if we add 300 to 400, that would bring us to 700 here, okay, in a 10-minute time interval from 20 to 30 minutes. So we're up here at 700, right? We go over 10 more minutes, and now we're plotting 300 more, right? From 400 to 700 is 300 more, and we plot our dot. Notice your graph should be going up, 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 up the entire time. For a speed time graph, anyway. Now, we keep going, and the next time interval is from 30 to 40 minutes, and we're going 400 more meters up. Okay, so from 30 to 40 minutes, we're going 10 more minutes over, and we're going 400 more minutes up. So 700 plus the 400 puts us at 1,100, which is right here. So we are up to this point right now. Okay, we're up 400 more. Okay, then we're at that 0 mark. Okay, for 10 minutes, we have no area, which means we have no increased distance. So that means we remained at 1100, a position of 1100. So I'm going to go 10 more minutes over, and I'm just going to make a dot right there. Okay, and then 2 more line segments to make. For the next 5 minutes, from 50 to 55 minutes, we're going 300 more meters. So 300 more than 1100 is 1400. 1400 is, of course, right there, halfway between. And so that puts us right there. And then the last time segment is 100 more than 1400, which would be 1500. That would be our last one. We go 5 minutes more and then up 100 more meters. Okay, now the last thing we need to do is simply connect these dots to create our position time graph. So here's our first segment, our second segment, our third segment, our fourth segment where we had no area. Oops. 6 and 7. This is how we construct a position time graph from a speed time graph.